Right. So we are starting phase diagrams. So the triple point is pressure and temperature at which all three states of matter exist. Simultaneously. It's not going to make sense right now, but when we draw the picture and identify where the triple point is, it will make sense. So just wait until we get to the diagram. And the critical point is where the liquid and solid phase has no boundaries. So it's not going to make sense until we draw the picture. And let me just make sure. Does this need a little? Okay. So with the phase diagrams and the heating and cooling curve, essentially all you need to do is know how to read a diagram. That's it. And extract information from it. So let's go to the picture. So my picture, I'm going to put it right here. So what you're going to start off with is a shape that looks like a sideways Y, like this. Kind of like a wishbone from a turkey. If anybody's ever, has anybody ever broke the wishbone for good luck? Okay, so that's usually when you have your turkey. It has like a little bone that looks like this, and you break it. I think one person puts their hand on one. I don't know. Yeah, you both put your hand on one, and whoever breaks it has the biggest piece. So does the other person get bad luck forever? Oh. No, oh. All right. So after I make my little sideways Y, now you put solid, liquid, and gas. So those are the three states of matter. For the vertical axis, that is going to be your pressure. And for the bottom, it's going to be your temperature. So now all we have to do is label it and read the diagram. Actually, it has some numbers here. I'm going to put 0 right here, 100 right here. We have 0.06 in the diagram. We have 1, and then all the way up here, it's like 218 for pressure. So this is how you interpret the graph. When you're going from a solid to a liquid, what is that called? Solid to liquid, melting? Yep, so look at, I put an arrow going from solid to liquid. This is melting. What's the reverse? And that's not just for Eric. What's the opposite of melting if I go from a liquid to a solid? Freezing. So see how we're labeling them? Yeah. What about if you go from a liquid to a gas. Starts with an E. Evaporate. So I'm going to make liquid to a gas. That's evaporate. What about if you go from a gas to a liquid? What's the opposite of evaporate? Think about when you have a cold glass of ice water, all right? And then it starts to get a little droplets on the outside. Condensation, that's the opposite. Morning. Don't forget your folder over there. All right. So now the other two phases that you may not know. Going from a solid straight to a gas. This is how I remember it in my head. Solid starts first with an S, straight to a gas. This is called sublimation. And Levi, don't forget your folder, please. So there's sublimation, and the opposite is deposition. Since we're starting with an S in solid, going to a gas, since we're starting with an S, that's how I remember it's sublimation, because that starts with an S. Because that's all right, because it's so easy to confuse sublimation with the opposite. And I'm going to write the opposite here. Deposition. This is going the reverse, a gas straight to a solid, skipping over the liquid phase. So sublimation and deposition skip directly over the liquid phase. So the solid to a gas phase, you can think of like dry ice, because you have that solid dry ice, and then it just becomes a gas. It doesn't become a liquid. Um, I gotta think about that one. All right. All right. So this is all of the freezing, melting, evaporate, condensation, sublimation, deposition. So all of you were able to interpret what is going on as you pass through a line. Now let's get to the triple point, where all three phases exist, which is right here. I'm going to put a little circle right there. That's the triple point. So at this point, for the substance, it's like a blend, a mixture of solid, liquid, and gas, but only at that particular pressure and temperature. So this is where you have solid, liquid, and gas just coexisting. Based on your picture, put a little circle at the end of this line here, depending on how long you stretched your line out here. Put a circle at the end of this line here. This is what we call the critical point. That's the critical point. If you look at the critical point, see how I can tell this is liquid, this is gas, this is liquid, this is gas, you're going to get to a point where you can't tell liquid from gas. This is what we call it becomes a supercritical fluid. There's no boundary between the liquid and the gas phase anymore. All right. We had this line for separation and then it kind of disappears after a certain pressure and temperature. If you look at the end where this critical point is this a high pressure or a low pressure? All right. So I'm going to put right where the critical point is, I'm going to put high pressure. And what about temperature? Would the temperature be high or low? So it has to be at high pressure and temperature. That's where the critical point falls, depending on the substance. So this is how to read a phase diagram. All right. My computer people, how much time I got on this? Oh, I got time. Who's my computer student? I'm gonna give you this. See that picture right there? Okay. I'm gonna give you this is the paper. Oh, wow. Okay, never mind.
That's right. So
Wow. Okay, so now I'm gonna fill in the notes at the bottom, and then I'm gonna end this recording. We got 3 minutes on this recording left. All right. So for every substance, the phase diagram is different. Water has a negative. I'm going to put a minus there. It has a negative, let me write it out, slope line between the solid and the liquid because the solid is less dense than liquid. The melting slash freezing point for water is 0 degrees Celsius. The boiling slash condensating point is 100 degrees Celsius. And normal refers to 1 ATM. ATM is a unit of pressure. I'm going to write pressure under it, which is normal atmospheric pressure. We're going to eventually do an endothermic, exothermic lab. So you'll notice that it'll be in Ziploc bags and the bags will either get hot or cold. If it feels hot, it's releasing energy. Exit. Okay? The temperature should decrease eventually because it's releasing so much energy. Actually, we don't need to know that part. Endothermic, inward, you're absorbing heat. Okay. We don't need any of these.